All right, I'm going to go ahead and do a quick review since we just got back from break, and I know some of you ate a lot of tamales and had no time to look at your algebra notes. Although some of you did, I appreciate that. So, number one, look at number one. It says solve two ways. So, if we solve two ways, that means there has to be two ways of solving this one. Now, what we're looking at for number one is a system of equations. Why is it a system of equations? Because we have two or more linear equations. Do we have that? Yes. Do they have the same variables? Yes. Therefore, to solve this, the first way that I showed you was by graphing. Let me bring a graph here. Can we graph these? Yes. I'm going to graph the first one. If you haven't graphed it, let's graph it together. You should have a graph paper in front of you. It should be on your right-hand side, not on the left hand, or else it's upside down. So let's see. I'm going to graph the first one in red. What information do we need here to graph? We need the -2. That's my y-intercept, so I plot that right there. What else do we need? We need the slope. What is the slope for this one? -2, but in fraction form is -2/1. Therefore, that tells me 2 steps down, 1 to the right, we place a point. So we go 1, 2, 1 to the right, plot your point, do it again. 1, 2, 1 to the right, plot your point, do it again. 1, 2, 1 to the right, plot your point, graph your line. Should have your index cards handy, yes? Good. And then extend your line as far as you can, please, because for systems, I said, in order to understand or to see where they intersect, we need to extend our line all the way through, okay? All right, so we're done with that line. How about the second equation? Can we graph the second equation like this? Yes. You're saying, doesn't it have to be in slope-intercept form if we want to use slope-intercept form to graph? But isn't there a way of graphing it by looking at it like this? Yes. Bam, Jesse in the house. You would like the cover-up method. That is correct. So if from far away you cover up the x, what do you see? Y equals 8. That's going to be our first point that we're going to plot. Okay, there it is. Next, instead of covering the x, now we're going to cover what? The y. And what do you see? We see -2x equals 8. Divide by -2. And we're left with x equals -4. And that goes right there. And that's all we need to graph using a different method of graphing. Now, for those of you that forgot, the methods of graphing are, the very first one that I showed you guys was using a table. You guys remember that? -2, -1, 0, 1, and 2. The second method was using the cover-up, which is this one. And the third method was the first one that we used here. We're using the slope and y-intercept. So here we go. Can we find the point of intersection now? Yeah, let me zoom in. I'm going to place a point on the point of intersection, which is right there. Okay, so what is my solution? Everyone. Very good. -2.5, because it's about right here, yes? -2.5. So let's see, -2.5 is about right here. Let's see if it matches there to the point. Yes. And what is my y value? 3. And that is my solution. Okay. But that is only one method. What method is that? By graphing. What is the second method that we learned? Very good. The second method on the right, on the left-hand side, on that blank space that you have on your paper, I want you to write substitution. Substitution. right next to the graph, right? You have the graph on your right-hand side, and on the left-hand side, on that same graph paper, you have a blank sheet of paper, right? Everybody has a blank right here? Graphing, substitution, yes? All right, let me zoom in, and then let me make some space here. So, I'm not going to zoom out. Let me do it from right there. What do we know about substitution? That one of the equations has to be solved for one variable. Do we have one equation already solved? Yeah, the top one. What does it solve for? Y. What is y? Negative 2x minus 2. It's called substitution because we're going to substitute this into the second equation. So instead of writing y, what do we write? Negative 2x minus 2. Negative 2x minus 2. I bring everything else down. Negative 2x plus equals 8. Line down the equal sign. Can we combine like terms from there? Yes. What is negative 2x plus negative 2x? Negative 4x minus 2 equals 8. What do I do from there? Plus 2 plus 2. Negative 4x equals 10. And then? Divide by negative 4. Divide by negative 4. X equals negative 2.5. All right. Am I done? No. Now I need the other equation. Y equals negative 2x minus 2. But instead of x, what am I going to write here for x? Negative 2.5. Bring everything else down. The y, the equals negative 2, and then the negative 2. So, what is negative 2 times negative 2.5? 5 minus 2. What is 5 minus 2? 3. Therefore, my solution for this one is negative 2.5 comma 3. Did we get that using the other method, which is graphing? Yes. And those are the two methods that we already know. And we finished that right before we went to break, yes? Everybody remembers that, yeah? Okay. Is it coming back? Yes? Okay, good. Because, hint, we might have this on a pop part tape. Yeah. Okay, we'll do it on Thursday. Okay, thank you. All right. Let's go to number 2. So any questions on the two methods so far? Graphing and substitution. We're good, right? All right. Let's go to number 2. Number 2, let me make some space here. It says to solve and graph. So line down the inequality symbol. We need to leave the absolute value by itself, so I need to divide by negative 3, divide by negative 3 both sides. I'm left with absolute value 2m plus 5. What happens to the inequality symbol since we divided by a negative? It switches, so we're left with 3. From there, is there anything else outside the absolute value? No, we write two inequalities. One for negative 3 and one for positive 3. Are we there? Okay. I bring this down. 2m plus 5. Since this became a negative, what happens to the inequality symbol? It switches again. 2m plus 5 greater than or equal to 3. Let's solve. Minus 5 minus 5. 2m less than or equal to negative 8. Divide by 2, divide by 2. M less than or equal to negative 4. About this one. Minus 5 minus 5. 2m greater than or equal to negative 2. Divide by 2, divide by 2. M greater than or equal to negative 1. All right, let's graph this. What is my dividing point on this one? Negative 4. M is less than negative 4. What numbers are less than negative 4? Everything to the left. This one, negative 1. M is greater than negative 1. What numbers are greater? Everything to the right. And what do you guys notice on this one? It's a 4. Therefore, solution set M such that M less than or equal to negative 4 or M greater than or equal to negative 4. Hands if you got that by yourself. Okay, good. Damn. Some of you just, I heard earlier what? Because it was Monday? I'm like, really? Are we doing yes? Okay, good. So that was our warm-up. So set that aside. You're going to need a blank sheet of paper for Cornell notes. You do need a fair model. Get that ready. All right. So get a blank sheet of paper for Cornell notes ready. You do need a fair model. And title your notes Elimination Method. Elimination Method. So let's recap so far where we're at with systems. Here we go. Systems of linear equations. What have we covered? We covered solving by graphing. Do we know how to do that? Yes. Solving by substitution. Do we know how to do that? Yes. And today we're going to learn a third method of solving known as elimination, also known as combination, also known as addition. But all three are the same. It's the same method. The only thing, they label it different ways. Everybody with me? So once again, all three of them are the same. Elimination, combination, and addition. So you remember what I just said, please. All right, so your title for your notes is Elimination Method. Elimination Method. So our objective for today, I can solve systems of linear equation by elimination. Let's read together. 1, 2, 3. I can solve systems of linear equation by elimination. So once again, we already covered graphing, substitution, and now we're moving on to elimination. What's our concept for today, Jesse? Everyone. Systems of linear equation. Yes. So write that in the center of your fair model, systems of linear equation. And without looking at your notes, I want you to give me a definition in your own words of a system of linear equations. What is a system of linear equations? Blah, 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 blah. Give me one example, one non-example, and some hashtags. Do that right now, please. And I know some of you are barely coming back. Your noodle's barely moving. Hashtag sleepless nights. Hashtag babysitting cousins. Hashtag flaming hot Cheeto life. Hashtag gamer forever. Hashtag slept till 3 p.m. Hashtag help clean the home. Okay. Hashtag wash the cars.
Oh, yes, there wasn't none of that. Well, I mean, not for me.
Oh, no, I know. Hashtag practice algebra.
Wow.
Woo. That's cute. No, it's good. It's good. All right, share with your neighbor your definition. See if they have something similar to yours. Okay, let's see. How about Melanie? What did you get for a definition? What? How about your neighbor? What did your neighbor say? She didn't talk? All right. System of linear equations. Two or more linear equations with the same variable. You guys remember that? Yes? Examples, non-examples, and a hashtag. You're like, oh, that's right. My goodness, too many tamales. Pozole, menudo, turkey, ham, turduckens. Bakis or whatever. Ooh. All right. So, at the bottom on your summary section, by the way, you already have this. This is just a reminder, a refresher, okay? In the summary section, write this question down. How do I solve a system of equations using the elimination method? You're going to answer that at the end by yourself. So write that for your summary section. And remember, reminder, for second semester, you're going to be filling out the summary. You need to have name, date, period on all papers. You need to have a title for your notes. Yes, because the next binder check, I don't want people's view. You wanted everything? Yes, I want everything filled. How do I solve a system of equations using the elimination method? All right. So, leave space for the steps underneath your Frere model and turn your paper over to the back, and I want you to write example Q. Example Q. Now, reminder, this second semester is going to go pretty quick, very quick. And I'm not talking about in regards to time. It seems like it's going to fly by, but I'm talking about concepts. Concepts are going to start coming a little bit faster now, so I need you guys to stay focused. Some of the timelines so you guys have an idea as to where we're at. Once again, you went from 7th grade to Algebra 1, which means we need to cover some 8th grade Common Core stuff. Is that correct? Yes. So what I did on our pacing, I left the 8th grade Common Core. Most of it we already covered in between with some of the lessons in Algebra 1, but the ones that we haven't covered, we're going to cover towards April. Why? Because I want it as close as possible to the SBAC, to the Smarter Balance Test. Does that make sense? Which means that we're probably going to finish most, if not all, our algebra by the end of March. What does that tell you? That it's going to go very fast. I need you guys to stay focused. Okay? So with that said, here it goes. It says example Q. Solve the system by elimination. They give us a system x minus y equals -1 and 4x plus y equals 6. So here we go. I'm going to go over this example by myself. I need you guys to pay attention, stay focused. I'm not going to talk. By now you should be able to follow. We'll talk it out in a little bit. I just want you to see the entire process. Therefore, writing utensils down, look up to the screen. Some of you are already behind because you're messing around and you're not even done copying the problem. And you're going to mess it up for everybody else, and I'm going to have to tell everybody to go back to the back and give you new seating arrangement. Stay focused, please. Ready? Here it goes. Elimination method. Don't look at me. Look at the screen. Here it goes. Elimination method. Talk it over to your neighbor. See what happened for this elimination method. We got it? Yeah? Okay, copy that. You got about 1 minute. Copy that. All right, example super cute. You don't have to copy the instructions, but look at the instructions now. It says solve the system by combination. What do you notice on the previous one? It was by what? Oh, so my bad. The previous one was elimination. What does this one say? Combination. But what do we know? It's the same. Is that correct? So copy the system. Example super Q, system given, x plus 2y equals -1, and negative x plus y equals -5. So now, look at the example that you just saw and you copied, and I want you to see if you can do this one by yourself. I'll give you about 1.5 minutes. Struggle through it a little bit. Look at it, see what you can do. Finish it off, and then we'll go over it. Ready? Copy that and go. All right, let's see. Leslie C. Let me get you started. So I'm going to do this, and I'm going to do this. Tell me what to do from there. Circle the x and negative x. Put a x through it because you do what? What is this called? Eliminate. Okay. Then what do I write underneath? Three y. Hands if you got up to right there. Okay, good. From there we solve for y. Divide by 3. Y equals -2. Hands if you got that so far. Okay, good. Next, Alexander, which equation did you use? The bottom one? Okay. Who used the top one? Who used the bottom one? Doesn't matter. No, you should get the same answer. Is that correct? So I'm going to use the bottom one just to make a point. Get it? Because it's just a, you get a point. Negative x plus y equals -5. But instead of y, what goes here instead of y? -2. I bring down the negative x plus -2 equals -5. Bless you. From there, add 2, negative x equals -3, divide by -1, x equals 3. Solution, 3, -2. Hands if you got that by yourself. That is correct. Yes, question? Oh, to use the top one? All right, let me do that. X plus 2y equals -1. Instead of y, we said we're going to substitute what? -2. Yes? So we get x plus 2 times -2 equals -1. X minus 4 equals -1. Do you see where I got -4? 2 times -2 is what? -4. So from there, plus 4, x equals 3. Did it matter which one I used? No, I get the same thing, right? How are we doing, all right? Okay, so by now you should be able to do this next one by yourself, yes? A little bit faster. Example omega q. This one reads, solve the system by addition. What do you guys notice now? It's no longer elimination, combination, it's addition, but what do we know? It's the same thing. So the system given is -2x plus 2y equals 4, and x minus 2y equals -7. Copy that and solve. You got 1 minute. Ready, go. All right, here we go. What'd you get for this one? Danny. 3, 5. Hands if you got that. That is correct. Let me go over the process to make sure we got it. So here we eliminate the y. Negative 2x plus 1x, that's negative 1x. 4 minus 7, that's negative 3. Divide by negative 1. We're left with x equals positive 3. From there, which equation did you guys use? The top one or the bottom one? Top one? Does it matter? No, I'm going to use the bottom one. X minus 2y equals negative 7. But instead of x, I'm going to write in there what? 3. Bring everything else down. Negative 2y equals negative 7. From there, I need to get rid of this positive 3. I subtract 3. Subtract 3. We're left with negative 2y equals negative 10. Divide by negative 2. Y equals 5. And that's how we get 3, 5. We got this? Yes? Okay. Let's look at what we've done so far. We started with this one. Pay close attention to this part. Started with this one. We went to this one. We went to this one. Are we there so far? But now we're going to this one. Copy that one, please. Example super duper cute. System given. Negative x equals y plus 4 and y minus 2x equals 5. All right, let's look at this one before we solve it. Do you notice anything funky about it? Let me go back to the previous ones. Here it goes, just in case you didn't see it. Here it goes. Look at that one, that one, that one, and now this one. Tell your neighbor what you need to do to that one, please. Nate, what do you need to do? Subtract y. Subtract y. Subtract y. So we end up with, I'm going to write it underneath, negative y minus x equals positive 4. Everybody see that? So we no longer use this one. Do we know what to do from there? Yes? So what is y minus y? They cancel. What is negative 2x minus x? Negative 3x. What is 5 plus 4? 9. Divide by negative 3. X equals negative 3. Which equation do we want to use? The top one or the bottom one? Okay, I'm going to use the top. Y minus 2x equals 5. But instead of x, I'm going to use negative 3. Y minus 2 times negative 3 equals 5. What is negative 2 times, what is negative 2 times negative 3? Positive 6 equals 5. And subtract 6 from each side. Therefore, y equals negative 1. Therefore, my solution to this system is negative 3, negative 1. Show me your fingers how comfortable you are with these. Got some 5s, 4s, 5 4s, 5 4s, 5 4s, 5 4s. A lot of you eat a lot of hot Cheetos, huh? All right. I know, you can see that. So, with that said, turn your paper over. We're going to get some steps. And you're going to come up with those steps. Step number 1. Who can get us started? Close. Paulina said eliminate. That is step number 2, eliminate. Step number 1, yes. Solve for y, let's see. Are these solved for y? What is this called, by the way? Talk it over with your neighbor. What is this called on all of these? What is step 1, people? Jerry. Bam! Set in standard form. Man, that was a swish from the corner right there. Boom. That is correct. Set in standard form. Step 2, eliminate one variable. Once we did that, what is step 3, everyone? Okay, let's see. Step 1, step 2, what is step 3? Solve for one variable. What is step 4? Substitute and solve for the other variable. And the last step that we didn't do on this one, but we know we need to do, is to check. Do we know how to check once we get a solution? Yeah, you take the 2 values, substitute into the 2 equations, and it should be true for both. Is that correct? So, for home plate tonight, you're going to go to page 300. I think it's only 30 problems. Just kidding. I think there's 7 problems, something like that. However, once again, if you need the extra practice, I'm going to be here for tutoring. If not, have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye. Don't forget to bring your corrections and your signed progress tomorrow. Bye.